Basically, there's this thing in to be honest, this is not a thing specific to blockchain. This is just something that's illegal and immoral, and it's not allowed. Basically, we're talking about preventing front-running attacks. We're talking about preventing sandwich attacks. We're talking about preventing people from just essentially, the whole point of a transactional system is so that two parties can transact, right? Without the concern of there being like a third-party player that commits fraud on them. And I mean, MEV isn't what we define as fraud, but it's immoral at the minimum. So I just get pretty mad about it, not really. So essentially, MEV, what is MEV? And why does it matter? I actually explained this in a previous talk. But MEV stands for maximally extractable value, minor extractable value. It's had a different sort of, MEV's meant a bunch of different things over time. Basically, the way that the blockchain works is a decentralized network. And it's all about the blockchain. It's a chain of blocks. And the chain of blocks is the source of truth. So when you're trying to do a transaction, especially when your transaction, you want it to make money, right? You're going to buy something, you're going to sell it, you're going to make a profit. You want your profit to be recorded on a source of truth, or else it's not risk. You don't have real profit if it's not on a source of truth. So essentially, we all want our transactions on chain. And when you make a transaction, it gets submitted to what is known as a mempool. And then this is when the miners mine the transaction. So essentially, you don't pay up front to submit the transaction, but you do pay a fee to confirm it. Now the point is that when you make a transaction, your transaction could be like, hey, I have $1,000 worth of Ethereum, and I'm going to sell it for $1,000 worth of USDC. And you submit the transaction on chain, and then a bot, let's just call it a bot, it sees your transaction. It says, hey, this guy wants to sell $1,000 worth of Ethereum. Why don't I just buy the Ethereum before he sells it, let him sell it and then buy it after, or vice versa, depending on if they're trying to do a buy and sell. Essentially, you can just extract profit out of people for free. The point is, the reason why it's immoral is because you don't offer any value to the system. Like simply miners extracting the value out of the chain doesn't make people want to use it more. It makes it worse. It makes it less efficient. It doesn't make it a thing of the people, right? So we've got various layers of MEV protection, and this is sort of the model I've came up with. So actually we have various levels of internet protocol level protections and stuff. This is more of a blockchain framework of the levels of protection against people essentially looking at your transaction, figuring out, hey, I'm going to do this, I'm going to do it before you, because I have the right to do it before you, and then I'm going to screw you over. Just being really plain and simple about it. That's exactly what they're trying to do. The MEV guys will say, they care, but they really don't, a lot of them, except for flashbots. Anyway, so we've got application layer protections. So these are owned by the DApps. So a DApp is a decentralized application. Essentially, this is like just a guy who writes some code, such as Uniswap. Uniswap implements an exchange, allows you to exchange one crypto for another. 1inch also does that, so does CalSwap. Frankly, these are all the same thing. They just have different technical implementations. Secondly, and this is the holy grail of protecting people from MEV, is consensus layer protections. So I guess if we were to try to understand the difference between these, consensus layer protections are the miners themselves being generous to say, hey, I'm going to offer you a section of where you can submit your transactions, and I promise you I won't screw you over when you put it into my little pool of transactions. Here's a bucket. You can put your transaction ticket in here, and I promise I won't screw you over. The only reason why the consensus layer protections exist is because Flashbots make plenty of money elsewhere. So this isn't a commercially viable model in the long run. The two models that work are the application layer protections and the protocol layer protections. And the last one is the protocol layer, which fundamentally is the proposer builder separation, which we'll get to in the next slide. I'm trying to go really fast here, guys, so I don't waste your time. So economically, the model that works to make MEV protection work at scale is essentially just a rehashing of the economic principle known as perfectly perfect competition, otherwise known as a market mechanism approach. Basically, it's just auctioning, a Dutch auction, until people bid down to the lowest possible price. Essentially, I'm just a guy, right, who has a margin that's acceptable, and I'm going to bid down till my margin becomes unacceptable, where if I bid any lower, I'm going to be losing money. Essentially, it becomes a competition of the guy that can operate at the lowest margin, which is really good when you're trying to protect against MEV, because you can't stop MEV, but you can make it very cheap for an everyday user. So we have an exchange called Uniswap X. Again, I'm just trying to get through this really quick. It's the most advanced application layer implementation of an MEV protection. The interesting thing about Uniswap X, they don't really have a commercial incentive for what they're trying to do, but they have a strategic incentive, because this, as I said, is illegal in traditional finance and immoral across all finance. It doesn't matter if it's decentralized finance. Vitalik himself doesn't like MEV. Anyone who's a core protocol builder really doesn't like this stuff, because it's just a bunch of guys that basically extract profit from people just trying to use the technology itself. It's not great. It's not a great situation. That's why we want to solve it. And so, miners don't profit either. That's actually what makes it such a good network, because there's a lot of people supporting the network for free, which we all derive as a benefit as everyday people. Now, this is the architecture of Uniswap X. It's pretty complicated, and I'm pretty tired to try to explain it right now, frankly. I probably should have just pushed this talk onto another time, and I had more effort to actually explain this stuff. But this is the smart contract architecture.
I'm interested in this arbitrage opportunity. Is something I can take advantage of, or is it only an arbitrage that someone can?
No, these are arbitrage opportunities that close in fractions of milliseconds.
Okay. So I've got to have a trading bot or something.
You need to be highly sophisticated. You also need to be a blockchain miner, Bitcoin miner, which means you need at least 42 ETH. You need at least $100,000 of ETH to do one of these opportunities. So this is like the holy grail of how we improve the blockchain. Basically, how do we make the blockchain less immoral, like, you know, you're not getting ripped off every day with some bot taking a percentage of your transaction. And it's applied across the whole of the protocol. Now, the interesting thing is that Uniswap X works across chains. This only works on Ethereum. So it really depends on what kind of world of blockchain you believe in. But this is the Ethereum solution to the entire Ethereum ecosystem problem. Now, originally we started up here, and this is a great life cycle of how a transaction gets added to a chain. So originally, you say, I want to trade $100 of Ethereum for $100 US. And then you say, cool, I want to do that. You click the button on your computer, it goes to the mempool. Now there's a bunch of guys sitting around waiting to say, okay, cool, I've got your transaction, now I'm going to confirm it in the mempool. And they do that by doing a bunch of work. They prove their legitimacy to be allowed to prove your transaction and submit it on chain. Now, this whole point of view where they get to see a transaction in the mempool, and they are also the ones in control of essentially adding a transaction to the mempool, means there's a buffer in there. There's a buffer in there where they can look at your transaction before it's added, and they can do some funny business to try to front run you, sandwich attack you, do all kinds of things. Basically, if you know what's going to happen before it happens, that gives you a big advantage, right? And this is what the miners have over everyone using the blockchain today. They have this massive advantage where they can see everything that happens on chain before it happens. It's not just that, they have the right to choose what happens. That's a really big risk.
So it's the Robin Hood of blockchain.
Yes, and right now, to be honest, if you think about the game theory of the chain, there's so much money coming on chain. It's not within their best interest to make the chain whole, ruin it, whatever, but it is within their best interest to capitalize on just taking a little small fee, sliver fee on every transaction to the point nobody really notices. And they're just extracting lots and lots and lots of money out of absolutely everyone. So we move on to proof of stake, which is the latest version of Ethereum. And instead of the transactions being selected by the miner, they get selected by the validator. Now the thing is, this is exactly the same. There's practically no benefit to the user at this point. So now we're into proof of stake plus propose and build a separation block.
What's the energy saving of proof of stake over that old system?
Proof of work, basically proof of work is that if I want to prove my legitimacy.
Yeah, but it saves. It's about
like
saving
99.9%.
It's 99.6.
Yeah.
It's effectively this uses no electricity, and that does. The only electricity in proof of stake is just the electricity to just literally run computers, which is the whole stuff. So now we move on to PBS block cycle. And frankly, this is wrong. MEV is still possible. But the point is that instead of a miner getting to control the process of a block getting added to the chain, you essentially have what is known as a builder and a proposer. Now a builder basically is the guy that receives the transactions. So there's 1,000 people around the world, they want to do transactions, they go to the builder guy and they say, hey guy, I want to do a transaction. The builder guy only has the capacity to handle 100 transactions at a time. So he'll just pick 100, maybe the first come, first serve, whatever. He picks 100 transactions and then he submits that batch of transactions to the proposers. The proposers are another network of people on the opposite side who are competing to be the ones that get to build that block. So now you've basically separated out the concern, where you've got the guy building the block, aka the guy that has control over the ordering of transactions. And then you've got the guy who actually adds the block in, is the separate guy. So now you've effectively removed the concern from the guy being, if I get to build the transactions and submit them, it means I can reorder them. And I'm the only guy in control of this whole scenario. Now you've got a two-party system. You've got a guy that builds it and a guy that proposes it. And the proposer options for the right to take the builder's order. So now you've removed the ability for people to profit unless there's a final scenario. And this is where people make real money in the world. You get a highly sophisticated financial actor that is both the builder and the proposer,
Exactly.
and they work in tandem together.
It's collusion.
So this is my new plan.
This is where Dutch option doesn't work.
This is my new plan to be both the builder and no. But basically what I'm saying is this is a great solution. Obviously it's not the perfect solution, there is no perfect solution. If you're determined enough and fraudulent enough, you'll get away with it. Now, last bit of advice, I want to keep it quick. How do you protect yourself today? Really simple. You can protect yourself today. You can add in RPC, called rpc.flashbots.net, or there's plenty of others, MEV blocker, MEV protect. Basically, this guy here, I met this guy, the Flashbots guy. He's just a really nice guy. He's made a lot of money, and he's like, hey, I care about this, care about this technology, and he's like, hey, I'm just gonna create this separate set of validators that are gonna accept your transactions, and we're not gonna mess around with it. Because we care about the long-term viability, and I'm a nice guy, and all that, basically. That's why this exists. It's generous. Whereas proposer build separation and Uniswap X and the application layer are not generous. They're based on a profitability market mechanism. Whereas this guy's just a nice guy. So that's it. You can protect yourself today from MEV. Just use like an RPC, like MEV Flashbots Protect. Basically, all of these transactions go into like a private mempool, which is run by a bunch of guys that won't screw you over. So,
Are they members of effective altruism?
I would say if they're a member of effective altruism, I'd run for the hills at this point. Because FTX didn't turn out too good. What did
It's like
turn out too
effective
good?
contraception.
FTX.
Too effective.
Anyways, that's it, guys.
That's actually pretty awesome. Any questions for Beau? You good?
Yes. Pretty random. Yeah, nice one.
So Jordan over here sits next to us. He couldn't make it today, but he runs about 30% of Polygon's MEV.
I would have loved for him to be here for me hating on MEV the whole time.
I know, right? So if he managed to get 51% of the MEV, like, would he be able to become, you know, like able to control Polygon essentially?
Well,
Minor,
what, I don't really understand. It depends on the chain. Different chains also have different consensus mechanisms. Polygon is very different to the rest. It's actually a side chain. It's not a ZK roller.
Yeah.
So yeah, it really depends on the network itself, architecture. I mean, if he got 51% of the he couldn't get, because the validators of the proof of stake network are not the same people as the people trying to do the MEV. But he'd be basically taking 51% of the MEV profit share. And at that point, it means you have like a really strong kind of weight to throw around in that space and on that chain. So it's a good place to be in.
Scale helps.
Having 51% of anything is a good thing.
I had a comment just on the industrial applications technology. I know it's like man-in-the-middle attacks seem like they're a little bit of a product of sort of a cryptography and the function. And a lot of sort of trade-based organisations, for example, do have the import-based fraud is actually the most predominant type of fraud. Is there something there in terms of that engagement with the MEV and that can be augmenting those sorts of additional concerns in terms of, you know, security or transaction security from a real world perspective? And is there an overlay there that you envisage or?
That's interesting. I mean, largely, like, the solution we employ is just market-driven mechanisms, which is largely the solution everywhere
Solving
else.
a problem that is pre-existing on Ethereum, for example, in this instance.
And I, like I said, like, I think you've either got market-driven mechanisms or a really nice guy.
So trust is still there to a certain extent?
Oh, hell yeah.
Okay. Okay. Not going
Hard to
trustless just
remove.
yet.
Yeah, it's hard to remove.
Right.
Alright, that's a wrap, guys.